And feel free to interrupt anytime if you have questions, or you can always wait till the last 5 minutes to ask us questions. So there'll be just an overview of what we're going to be talking about, and in addition to that, there'll be some demos on some machine learning, and also there'll be some videos that we'll have as well. So to set up the talk, always have some sort of a story. So when you think about the opportunity and the opportunity from a data perspective, you'll see that there's approximately 1.6 trillion in terms of data dividends available for businesses to embrace over the next 4 years. So the opportunity is great, not just for companies, like Microsoft, but for partners out there to interop with us, to engage with us, to take advantage of the data dividends that are available. Data is becoming the new currency out there for the century that we're in. There's diverse data, new analytics, and by combining those two, we have this new currency, a new formula for this new currency for you to be able to reach more people. And how's that done? That could be done through what we have today is called the data platform. Previously, the data platform, when you talk about the data platform, a lot of people would say, well, the data platform is SQL Server. The data platform is reporting services or analysis services. Well, it's bigger than that today. And an easy way to think about it is you want to capture your data, you want to manage your data. And it's not just relational data that we have available today that you store in SQL Server. There's various forms of data. This is the infrastructure layer that we have available. Non-relational data, no SQL, things like DocDB, streaming, and also the internal data that we have, data marketplace, or data that's stored on-premise in your data warehouses, or external data. That's where you, the interop partners, come in, because there's an opportunity for you to host your data in places like Azure Marketplace and create revenue off of that. And once the data is there, you need to think about transforming and analyzing that data. And when we talk about this, it's not the traditional way of data in your data warehouse. You do your ETL, extract, transform, and load. There's several tools and several methods that we have available today. There's streaming through complex event processing or complex event streaming. There's machine learning, where my colleague Mark Stafford will be walking you through a demo later on today. Orchestration. And then once you have transformed and you begin to analyze that data, the next step is figuring out how to visualize that data. And visualizing that data now is being brought to several people out there, not just your IT reporting guru who would be able to create these reports for you and then publish them out. But now data could be pushed to the masses through Excel, different tools that the average person out there, the business analyst who's in their office, can quickly load up Excel and figure out different trends in the organization by looking at data that's been captured, that has been transformed, and allows them to analyze them through tools that they're familiar with. They can create reports through Power BI. They can create dashboards. They can use natural language query, ask questions, Q&A, what's the weather? And based on the different models we have behind the scenes, you'll be able to provide them with rich data in forms that they can easily digest. And also, it's not just something that you could do on your desktop. It's something that could be done on various mobile platforms, and not just Windows. It could be done on Android. It could be done on iOS as well. So from looking at this data platform that we have available, you can see the interop surface area is great. It's something that we, as Microsoft, can't do by ourselves. This is where we're looking for partners to embrace, engage with us on these different layers that we have available out there. So think about ways you could partner with us, whether it's through the visualization layer, through Excel, through Power BI, or whether it's through the transformation layer, through processing, or if you're experts in the capturing and management space, figure out where we can engage as well. So now I'll be handing it off to Mark Stafford, who is a demo. So there'll be a demo and a video, and then we're happy to answer any questions that you guys might have. And we'll be here all day and be able to talk in depth about whether the BI stack or data. The two of us will be here to address those questions you have. So handing off to Mark.
Test. Perfect. Great. Thank you. All right. How many people have heard the story of the connected cow at this point? Has anybody heard it? No? Good. All right. I get to be the first person to tell you. So, so the connected cow is a really, really interesting story that helps to demonstrate some of the breadth of the platform that we have built so far. And I really do want to stress what KB has said. We have built a lot of components. Most of them have some sort of integration point. And while our vision is big, our vision is much bigger than what we can actually deliver on. So we really are looking for people to fill various gaps. And the data space is huge, right? Everybody has data. Everybody has value to add to that data. So please think creatively about what you can do. That said, the connected cow came out of Japan. Japan has a major problem with space and being able to reproduce cattle and things like that. And I don't have the slides that go with this talk, so you're just going to have to use your imagination and visualize this connected cow. There was a farmer somewhere outside of Japan, and he wanted to be able to detect better when a cow was ready to be artificially inseminated, so that his conception rates would go up. And he partnered with Fujitsu, who turned to Microsoft to figure out how to solve this problem. How could they get higher conception rates? Long story short, and you're missing a bunch of the jokes, so go out and watch the real full story of this. They discovered that if they could measure when a cow was walking, they could actually detect very accurately when it was going to go into estrus, when it was going to go into heat. Cue the joke about a heat map, right? And even more so, as they continued to look at this research, they found that 16 hours after the cow goes into estrus was the optimum time to artificially inseminate the cow. Unfortunately, the cows normally go into estrus in the middle of the night, from 10 p.m. till 8 a.m. in the morning. The farmer has worked a long day. It's very difficult to detect these sorts of things happening. So how could they monitor this and have some sort of automated notification that, hey, look, it's time to artificially inseminate this cow? So what they wound up doing is they actually strapped a pedometer to the cow's leg. So it would measure the number of steps that the cow was taking. And they found, as they did the research, that the cow's number of steps would increase dramatically when it was going into heat. And so they could detect very, very accurately when it was time to artificially inseminate the cow. And so now, rather than the farmer having to monitor the cows and make sure that everything happens properly, he's able to get a notification, on his mobile device or whatever, that it is time to artificially inseminate this cow. The results have been huge for him, and obviously the story is great to tell. So what are the pieces that make up this story? So you have to have obviously a device, right? So there's literally a pedometer strapped to the cow's leg. That pedometer is talking to a local Wi-Fi device in the barns and around the barns and stuff like that. And so we've got Internet of Things, and Azure has a whole offering around Internet of Things and being able to report big amounts of data into a central pipeline. From the Internet of Things, it goes to a particular product called Azure Event Hubs. And Azure Event Hubs allows you to process just tons and tons and tons of data. If you've got streaming events like click logs or any major amount of data, really, Azure Event Hubs is a great way to land that data into Azure. From there, we're going to look at some of the other products that we have. So let me see if I can draw on the screen here. So there's this product here called Complex Event Processing. The official name of this product is Azure Stream Analytics. it allows you to generate insight over that data stream. So you can do windowing operations, and you can say things like, please tell me if nobody has tweeted about this particular topic in the last 10 minutes, or please tell me if the number of tweets goes up by a factor of 10, or any sort of windowing operation. Really, you can look at history and compare events and things like that. All this stuff is happening and generating data. The data can land any one of a number of places inside of Azure, and then we can report over the top of it with the visualization options that we have. And most of these are Power BI and related. We'll see demos of all these different components, but it's a great end-to-end story that kind of illustrates why we need a full platform and multiple different products. A different story. Sorry, let me change my mode here. How many people know this company? ASOS? Couple? I hear that they're much bigger in Europe than they are in the US. So ASOS is a company that's based somewhere here. And they also had a very specific problem. They want to increase sales, obviously. And they wanted to leverage a whole bunch of different solutions to be able to make product recommendations, be able to make better product recommendations. So what they're doing with the platform is they are analyzing their click logs, right? So they're sending all their click logs up to Azure Machine Learning, and based upon machine learning algorithms, they are actually able to generate much better product recommendations for their customers. So again, they're using a gamut of products. They're also using Azure Stream Analytics. They're using Azure Machine Learning, which we'll look at. And they're getting the data back out of Azure so that they can integrate it back with their system and make better product recommendations. So let's take a look at a couple of these products. We'll start with Power BI. So Power BI is just a product for doing visualizations and dashboarding and a variety of stuff like that. It is a fairly new product, and it is extremely easy to use, so anybody can sign up. And you can just do something like get data. And we will go grab some data from GitHub, but there's a whole bunch of data sources already. You can get data from Google Analytics or Marketo or Salesforce or SendGrid, and these will of course grow over time. So we're going to say, we'll go get some information on OData, since that's the product that I work on. And Power BI has a bunch of pre-canned visualizations, but it's also a very, very extensible thing. So there's actually a separate product that you can download from the site called the Power BI Designer. And this will allow you to connect to a bunch of data that's not already in the pre-configured connectors there. So for instance, you can see here that I was working on setting up a report that's connecting to Hadoop, right? So I've got some Hive queries out there and some Hive data stored in HDFS. Oh, I'm sorry, I'm stuck on authentication here. And my screen resolution is such that it's going to be maybe I can scroll down. OAuth 2 authentication. And so now it's going to bring in all the data. It's going to set up a dashboard and kind of pre-configure the dashboard, and we can see some of the data from the commits and check-ins and who's committed the most code, how many lines of code have been committed. All this is working against the live GitHub APIs. And similarly with Salesforce and Marketo and all those other data sources, we're writing connectors against their APIs as well. KB mentioned the natural language questions that you can pose to these data sets, so we'll try to take a look at that as well. And our new dashboard is ready. So just with that, we're able to see all sorts of interesting stuff, like Lewis is the primary contributor to the repository, but we've got a whole bunch of contributors who have contributed more than 2.5% of the total code here. As we click around here, we can get into more detail. So we can see count of distinct committers by month. You can modify any of these reports. And we can do things like commits by committer and total commit, I guess. And dynamically, it's going to do things like generating graphs and so on and so forth. So as bar graph. So this was the live Q&A type stuff that you can do. So Power BI is just kind of the top of the stack. It allows you to do reporting. There's a whole bunch of other infrastructure out there that's important as well. So let's take a look at some of the other components. So back out here. So Azure has many, many, many different components in it. And I want to stress that most of this is very flexible. So even if we do offer a first-class solution like Hadoop hosting, you can also go out and you can just set up a VM and you can host your own Hadoop clusters. So if you don't feel confident or are not able to, for some restriction purposes, host your data inside of Microsoft's Hadoop clusters, then you can actually set up your own VMs and have literally physically distinct HD Insight clusters. But we do offer many, many important products. So HD Insight is just a Hadoop distribution that runs on Windows. It is hosted as a service, and so you can easily spin up clusters. You can provision on demand. And so they've done all sorts of really interesting demos. There was a demo that you should go out and watch if you get a chance, where they were processing the human genome and just talking about the amount of processing that it takes to process the human genome and how it's come down over time. And so what they did is they took, there's a database of public genomes. 1,000 people contributed their DNA, and it's actually recorded in this public repository. Each DNA strand, when sequenced, results in about 2 gigs worth of data. So what they did is they went out and processed all this genomic data in literally just seconds by spinning up a huge number of Hadoop clusters. Virtual machines, of course, right? You can do anything you want to with that. Some of the other key things that we want to point out here are under Service Bus, we have the ability to create things like event hubs. And event hubs are a really good way. So Service Bus, so we've got Event Hub here. Event hubs are a really good way to get data into Azure from something like an Internet of Things. So if you've got that pedometer strapped to your cow or your cat or whatever animal you want, then you can get that data into Azure through event hubs. We also have things like Stream Analytics. So Stream Analytics, we said did the windowing operations, so you can configure, it's not doing anything right now. You configure 3 things for Stream Analytics. You need to provide it an input, where is my data coming from? In this particular case, we're saying that our data is actually a data stream that lives in Event Hub. We're going to say, where is the output of this thing going to go to? We're going to output it to blob storage in this particular case. And then you just pose a query that looks a lot like SQL. It's not exactly SQL, has a little bit of differences, but it looks a lot like SQL, and so people who are familiar with SQL will be able to learn this query language really quickly. But this query language helps us to do things like, okay, if I'm processing a bunch of temperature data, how am I going to deal with that? So in this particular case, we're saying, hey, look, if there's a spike, then I want to go get that information, and I want to use a tumbling window, right? So over the last 20 seconds. There's actually 3 types of windows. If you, again, dig into Stream Analytics, then you can get documentation on what those different windows do. I'm just trying to provide an overview here of the different things that are out there. In addition to Stream Analytics, we have machine learning, which was right above it. So machine learning, we can open it up here. So we're going to open up ML Studio. So everybody's familiar with the basics of machine learning, you have a bunch of data that you start with. You train a machine learning model, and based upon the training of that machine learning model, your model can now make predictions for you. So if you've got a whole bunch of historical data on the weather here in Saragossa, then you can throw that data at a machine learning model. You can train that model, and then you can evaluate new things. So we can say, okay, it was 37 degrees yesterday. Based upon historical data, when it was 37 degrees on May 13th, then May 14th is likely to have this particular temperature. My sign into ML Studio did not go. So let's take a look at what it looks like. So I have one experiment set up here. If we go expand this experiment, we can look at the diagram surface. And this just gives you a diagram surface to work with, primarily because the people who are doing this are not programmers, right? The people who are processing these models are data scientists, and there's a whole new generation of people who are going through proper data science curriculums in college, and they're being trained on how to do data science. But Azure Machine Learning gives you an easy way to host that in the cloud, scale that machine learning experiment, and actually, as we'll see, you can publish it and then monetize what it is that you're doing. So to build this diagram surface, you can do all sorts of things. You can browse through the tree here, and you can get different data sets that you've either published or are publicly available. You can search through this tree if you don't know what you're looking for, and you can say, I need a jungle, right? Which is a certain type of decision tree. And you just kind of drag and drop things together. So if I didn't have this connection, right, then I can just kind of drag and snap it together. So it makes it really, really easy to build a machine learning algorithm. Once you do that, you can actually run the model. Oh, demo fail. Yeah. Well, we'll see if we can get it back here. Please try refreshing the page, it said. I may have confused it by doing that weird connection. Okay, so now we're running through the experiment. It does do all sorts of smart caching, so you can see the steps that have run. If you wind up changing a step down here, it's going to have all that information cached from before, so that you don't have to rerun it. So just some optimizations. The important part is, hey, look, once you've got something that you think is worthwhile and you want to be able to use it at scale, what can you do with it? Well, there's two things that you can do with it. They're down here at the bottom. Number one, you can publish it as a web service. And when we do that, it's going to do a couple different optimizations. It's going to introduce a web service input and a web service output. So with the temperature data, if what we're doing is based upon yesterday's weather, we're trying to predict today's weather, well then you need yesterday's weather. So you need the date and the temperature that it was yesterday. So those would be the inputs. The outputs would of course be whatever your machine learning algorithm is doing. These are published as OData services, so anybody can connect up to them. They are publicly available OData services. There is authentication involved, of course, but you could connect Excel to it, you could connect Tableau to it, you could connect your OData client to it. Similarly, you can also publish these machine learning experiments to the gallery, at which point in time you can monetize them. So you can start charging for your different machine learning workflows. So, show one more thing here. So we'll go how old.net. So this was another thing that they demoed recently. So howold.net is just a way to demonstrate the interesting parts of machine learning, right? So we can do things like saying, okay, let's use this particular photo, maybe, if I can actually click on it. And so what it's doing is actually doing face detection, right? And based upon face detection, it's saying, okay, based upon all the other faces that I've seen and the data that we've trained it with, so somebody put in a bunch of faces, the genders of those people and ages, it's actually able to do predictions based upon gender and age. This tool was actually really funny. There was something of a virality around it, and so people started tweeting about it, and all of a sudden pictures of zombies and other interesting things started showing up. So if you want to go have fun with it later, feel free. This is running over machine learning in the background, right? So literally Azure Machine Learning is set up in the background. It's being fed by Azure Stream Analytics, of course, and we're processing machine learning algorithms in order to do this face detection. That machine learning algorithm is published in the marketplace. So you can actually go use this face detection algorithm today and use it in whatever application you have. Any questions so far? You guys still with me? Okay, what else have we not talked about? Let's talk about Azure Data Factory. So, we're expired. Log back in here. So this is the new Azure Portal. We are gradually moving from the old Azure Portal to the new Azure Portal. It's particularly interesting because some people like one of the two experiences a little bit better, but let me sign in here, sorry. So the product that we're going to take a look at is called Azure Data Factory. When you've got all this data moving all over the place, how do you keep track of it? How do you understand what's happening? So if you've got event hubs, and you've got stream analytics, and you've got machine learning model processing happening, what can you do to understand the flow of that data, the health of that data, whether or not things are broken? Azure Data Factory is a solution that the larger team that I work on is building. And really what it does is make it really, really easy to monitor your data workflows. So it provides a single pane of glass where you can go out and you can get troubleshooting information. So I was working on setting up a particular demo, and this morning the demo broke, right? And so it's going to keep dragging. So we can see just by glancing at the page that some things are working okay, and some things aren't. And if I were to dig into some of this information, then it's going to give me detailed diagnostics about what's happening. So even though this particular thing happens to be out in Azure Blob Storage, I can actually go look at my data pipelines and really get a lot of detail about what is happening. So we'll load this up here. And we can see that earlier this morning I was having some data failures where it was failing validation. And that's because a particular file wasn't available at that point in time. So I can continue to dig in deeper and deeper, and eventually I'll get down to the very specific error message. Now, trying to track this information down when you've got a multi-step system, right? You've got a Hadoop cluster, and you've got something that's streaming data somewhere, and you've got all sorts of different things going on, that can be really, really difficult to track down. So Azure Data Factory is what kind of provides you that overarching ability to understand what is happening with your workflows. It also has first-class support for things like moving data around. So if you need to get data from Azure Blob Storage to Amazon S3 or something like that, it provides all sorts of different move capabilities as well. So, bunch of different pieces. I do want to continue to reiterate that, look, we've got this huge vision. We've got a really stable foundation, a lot of components going on. But there are a huge number of integration points here. There are many, many things that we just don't have time to write. So the Amazon S3 connector, I don't think we've actually written that yet. It's not about whether or not we want to write it. It's about we have a finite number of team members and we can only produce so much software. So there are huge, huge opportunities here for people to integrate. I think we're happy to entertain any sort of discussion or idea. Even if KB and I don't know the right answer, then we can absolutely connect you with the right people to have the discussion. So if you're interested in doing interop with these platforms, please grab one of the two of us. Like you said, we'll be here all day. But I think with that, we can open it up for questions. Or I can tell more stories if there's no questions. More custom stories.
I did try the howl.net with actually the anonymous face, and consistently it gave me 44 years old for the anonymous mask. About the APIs, can you tell us a little more about the APIs that are available, and is there opportunities for people out there to build new kind of APIs on top of what you already have?
Okay, so the APIs that exist today are, there's a variety of them, right? Because there's a variety of products. So some things don't have kind of first-class APIs, and it's because they're not really designed to have first-class APIs. So things like Azure Stream Analytics, I mean, it's taking an input that you configure, and it's taking an output that you configure, and so there's not really an API to be had there, right? It is a filter along the path. Other things, like Azure ML, do have proper APIs. Almost everything at Microsoft, not 100%, almost everything at Microsoft is going to the OData protocol so that it is standardized, right? So if you have an OData client, and there's OData clients in .NET, in Java, JavaScript, Python, C++, TCLTK, all sorts of crazy languages. If you have an OData client, then you're going to be able to connect to any of those APIs today and immediately start working. Was there a specific component that you were interested in APIs for?
Not necessarily, just...
Okay. So like there's some components that make sense to have APIs, like Azure ML. There's some components like Azure Stream Analytics that don't make sense to have APIs, but do make sense to have other forms of extensibility. So the form of extensibility for Azure Stream Analytics would be for you to say, okay, I want to connect that up to an SMTP stream, right? And I want to be able to deliver events to Azure Stream Analytics via SMTP or something like that. So all of our products are designed to be extensible, and we're trying to do a better and better job of interop. And it may not always be an API, but in other cases, it's a connector or building out some other component. Yeah, sorry.
When you said all products, to just kind of qualify all products in the data platform, we're not speaking on behalf of all the other teams at Microsoft as well.
I have a question about machine learning module. By the nature of such algorithms that work with machine learning, you sometimes need to adjust it and to even debug it, how on the fly, I mean. Debug maybe not, but adjust and provide more and more data for the machine learning thing. So how does this thing can work? So my question is twofold. First of all, if something goes wrong with your neural network in machine learning, how do you debug it? And how do you, is there an API to do those adjustments to the network on the fly?
Yeah, so fantastic question. And you're going to have to bear with me. Some of these products I am not a full expert at, so I may have to get you the answer offline. So what I do know is that you can visualize all of the outputs as you're walking through this thing, and I believe that it has like actual debug functionality built in. I don't know exactly how it works right now, so I need to figure that out. But the important thing is, hey, look, let's say that you're not satisfied with the machine learning algorithms that exist in here today. There's all sorts of different stuff that you can do. So if you do have something that you trust, with machine learning, it's probably written up in R somewhere, and you can literally just drop R scripts, right? So you can drop a full R script into machine learning, or a Python script, right? So Python's in there as well. Virtually everything that gets done in machine learning today is either R or Python, and so these are things that have their own debug mechanisms.
Is the learning code public as well? Do you know TLC?
I don't know. But so you can upload and create your own algorithms, and I'll have to dig into the debug specific question. I'm sorry.
You can use this only as a service, or you can also deploy it as a product for yourself if you don't want to share the data, for instance.
Can you explain what you mean by don't want to share the data?
Yeah, I picture out a company that doesn't want to share the data but want to do the analysis. So can they somehow deploy all of this in their own infrastructure,
like the
instead
like
of
how old?
Sorry?
Or you're talking generically?
Yeah. I'm thinking about, I want to do this kind of analytics that you showed, but I want to do it with my own data, and I don't want to share the data in the cloud for some reason. Can I do that in my own infrastructure by purchasing the product from Microsoft or something like that?
Yep. So Azure is an interesting product. We always get questions about what can I run on-prem, and I think part one of the story is, look, we've got really extensive hybrid capabilities. So this is one of the things that our VPs are always talking about in various keynotes, and they say, look, we're the only one of the huge world-class companies that's got data centers all over the world and does hybrid capabilities. So if all that data exists on-prem, there's a different component called the I think it's got a very glamorous name like Data Gateway or something like that. And what happens is you set it up on premise. It provides an OData feed that you can connect to from machine learning. So the machine learning is still happening in the cloud. I don't know exactly where they're at with specific features, but I know that at least on their feature list is the ability to mask certain data. So if you've got private data, then you can mask that as long as it's not necessary for the machine learning. As far as being able to run everything on premise, I think that's a work in progress. And what I can say is I know that we do a lot of things based upon customer asks. So the more customers that ask for this particular thing on premise, the more likely it is that we are to productize it in a form that you can run on premise. But you can keep your data on premise, for sure.
I have a question.
Yep.
So I think the foundation for this is actually where the data comes from.
Yeah.
You showed several sources of data,
Yep.
like GitHub, like
Yep.
Google Analytics.
Yep.
All those are related to your account, to the thing you have. But you also mentioned in your examples many useful data that comes from public sources, like
Yep.
temperature, for
Yep.
example. Do you have any source or some repository of this open data so that people don't have to look for it? Because it's open, it's available.
So this is where I get back up on my OData soapbox, right? In my standardization of APIs soapbox, and if you didn't hear the API talk the other day, please come talk to me about standardizing your API. Look, it's growing. So there are places like, and you're making me remember all sorts of crazy URLs. So let's see. So let's just do a search. Socrata, OData. So Socrata is an example, right? Socrata does a lot of government data, and this happens to be one data source, right? They expose their data as OData. And so you can go get a whole bunch of different data from the White House. But to some extent, like, we're dependent on those public data sources exposing their data in a way that we can consume. So we do a lot of work to be able to consume lots of different forms of data. So almost every product that we build supports OData, but we try to support lots of other formats as well. So things that are high on the list are obviously CSV and TSV. Obviously the major data stores like SQL Server and Hadoop and Teradata and Oracle and so on and so forth. The non-relational databases like DocDB and RavenDB and all sorts of different stuff out there, right? There's a huge list of data sources that we care about. Literally, we talk about data sources in the hundreds. And this is like types of data sources, right? So we're always working to build that connector story out. It would be great if we had a standardized API so that we could consume everything, but it just doesn't exist today. So it's a work in progress. Anything else? All right, let me close with one last quick story. I'll try to make it really quick because we're 1 minute from the end. So one more story from Fujitsu. They had another situation where they wanted to transform a semiconductor facility that they were not using into a facility to produce lettuce. And they wanted to do that because there are people with kidney issues who need low potassium food. And so they oftentimes can't find low potassium food, especially with vegetables. So they have to boil their vegetables or something like that to get the potassium down to a reasonable level. Well, Fujitsu found that they could grow low potassium lettuce so that these people could have fresh vegetables, but they had to do it with very, very carefully controlled data. And since we are pretty much out of time, I'm just going to play the video, and if you're interested in getting more data about it, then I can share it with you afterwards. Can we get the audio? Good.
We live in a hyper-connected world. People and things are linked together, sharing information all the time. IT companies must be highly adaptive and innovative to drive breakthrough transformation. Fujitsu took its semiconductor factory and converted it into a plant-growing factory.
We had a semiconductor factory that was closed due to reduced production, and we wanted to put it to good use again, so we changed our product from semiconductor chips to lettuce. But the concepts of quality management, production management, and efficiency remain the same.
Fujitsu is addressing an increasing demand from Japanese customers for higher quality, more nutritious produce that maintains freshness significantly longer and is still reasonably priced.
In the past, Fujitsu developed various solutions for different clients, but we had a hard time interacting with the data.
Leveraging the Fujitsu Eco-Management Dashboard solution alongside Azure, we were able to deliver real-time visualization of the growing process and sophisticated analytics to improve the entire production.
With Microsoft Windows as our base, we use Power BI, machine learning, Steam Analytics, and Event Hubs running on Windows tablets. Our goal is to optimize factories in this industry and many others. Quality, cost, lead time, speed, environment, and safety are all significant factors to achieving this optimization.
With Windows tablets, we don't need to stay in the office to validate and analyze data. This is really important because it decreases the time and effort required for engineering. People can share their work immediately, and the data is updated in real time.
The integration of the Eco-Management Dashboard and leading technology from Microsoft is very significant for our business.
To us, innovation is solving agricultural problems while also changing the perception of the industry.
We can now achieve the goals that seemed impossible in the past.
Together with Microsoft, we are on the leading edge, combining our technologies to leverage the Internet of Things and people to help realize business and social innovations in this hyper-connected world.
All right, thank you.